Okay, fun recording. Welcome back. So next thing I want to take a look at is a survey that was done recently about opinions on how the media is covering this pandemic in the United States. And the Pew Research Center is a good one. Gallup Polls does some good research. There's a ton of research organizations out there. And sometimes news organizations do their own research, like big ones like the Wall Street Journal, the New York Times, Oregonian maybe. So this article right here caught my attention the other day. And it said, Americans' view of the news media during the COVID-19 outbreak. So this is some recent ones. And looking at this table over here, they've got Americans are more positive than negative about COVID-19 news coverage. And let me blow this up so you can see it. Let's see, open image in your tab, please. And blow it up. Fuzzy, but it's slightly better. So then they say the percent of adults who think the news media's coverage of COVID-19 outbreak is getting me the information I need. So 59% of people say, yeah, I think the news media that I look at is giving me the information I need about this COVID-19 outbreak. 59%, yeah, that's better than half. That's okay. We'd like it to be higher, but 59%. Now, they didn't ask me. Did they ask you? I don't think so. Who did they ask? So next thing I'd like to know about this is, okay, well, what's your margin of error? How many people did you ask? And I'm hoping they have a good way of doing a representative sample of people. And so generally, organizations like Pew will show you other parts of their report. So this article right here is geared toward your average person like me, you, or my mom. And some of this is a little more than the average person would want to see, but most of us, if we sit down and look at this, would understand most of what they're saying here. And then sometimes the news place like the Oregonian will then grab this and write their own version of it and link back to this. And then, so if I read this in the Oregonian, the Oregonian would link to the original article, and the original article goes back to the reports. Now, the complete report is kind of like this right here, this article, but with a little bit more detail. So if I download that and open it up, I can see at first it looks like they have a little bit of, how we did this, their methods, and then it's pretty similar to what we saw in their website. Notice that same graphic right here. Other page is the top line is what they call this part, and this is not quite their raw data, but it's like their first draft of the raw data. So the questions that they asked the people, some information about the question, and then the breakdown of answers based on when the people were asked. And so I can see the question that was asked. I can see some other information about the question and the number of people have answered a particular way about that question. And so one thing I can note here is they surveyed 10,000 people. That's a huge survey. Typically surveys like this are around 1 or 2 or 3,000. And they had 10,139 people in this survey. So I can see the sample size, so that's good to know. 10,000 is a lot. You don't see that too often in opinion surveys. And then if we try to search this page for like the margin of error, so if I do a control F on this page and I say, hey, where's the margin? It's not here. This is just the data. So they just tell me how many people they asked and what the breakdown for the answers were for each question. So that's there. So hopefully back on this other document, they tell me what the margin of error is. So sometimes you'll see that right in the description, but I didn't see it when I first read through. So I'm gonna click in there, control F, search for the word margin. Oh, they got some margins down here. So the data is reported, drawn from a panel wave conducted April 20th through April 26th. A total of 10,000 people responded out of 11,000 who were sampled. Okay, so they had a 92% response rate on this poll. That's pretty darn good. And then they go over some more details. Okay, so down here, the margin of sampling error for the full sample, the 10,000, is 1.5%. And some of the questions might not have been asked to all of the people. We're assuming the headline question was, but I would have to read more to figure that out. So they just gave me a whole bunch of information here, so I'm gonna grab this. line right here. Copy, and then notebook. And so I'm just going to kind of double check their data by playing around with it. So let's see, we need that. And let's resize you. Come on. Put you down here. And that's probably readable enough. And then let's get that graphic. It's way up at the top. Not that far, right there. Okay, so I just want that part. And current. Okay, so here's the information that relates to that one question I want to look at as I'm getting the information I need. So their P prime would be that 59%, which is 0.59 as a decimal. Their N, the sample size, is 10,139, and they're claiming that their error bound on the proportion, their margin of error, is 1.5%. As a decimal, 0.015. So that means if we were to turn this into an interval estimate, the low end of their interval would be the 0.59 minus 0.15. And let's see, what does that give us? That's going to give us 0.575. Yep. And then the high would be to add that. So 0.59 plus the margin of error. Oops, supposed to have a 0 there. 0.15. Did I still do that right? Yep. And so that would be 0.605. So what they're saying is that the actual proportion for the population, P, is somewhere between 60.5% as a percentage and 57.5% is what they're stating there. If we wanted to simulate this in StatKey, 10,000 is pretty damn huge. I think StatKey can handle it. We would have to find what X is. And so remember, P prime is always X over N. So X is always P prime times N. So we can find the X here if we just take 10,139 and multiply that 59% by it. And then once we have that value for X, then we can use StatKey to simulate this to see if StatKey gives a similar result. And so they did probably not do any simulations with this. They probably used the standard approach, which we'll talk about in a couple of weeks. And that would be in the fine print. So calculator, what is 59% of 1,139? Something's wrong there. 1,139? 139. Yep. Equals, and so it's about 5,928, 5,928. So that's our value for X, 5,928. StatKey calls this the count. Okay, so I think I got those in my head. So to re-simulate theirs in StatKey, I would just go back to proportion from mean. So this is like that problem number 10 we did earlier, just we have way bigger numbers. So 5,298 was my count. My sample size was 10,139. Okay, if I typed that right, I screwed something up. What did I type wrong? Calculator 5982. Right, digits wrong order. 5982 edits. 982. Do you guys transpose numbers occasionally? All right, there's my 59%, so I can see I typed it right. Thank you, Mindy, for correcting me. Good job. And then I just start generating thousands of new samples. Each one of these dots represents a different group of 1,139 people with slightly different opinions, randomly drawn from this deck of cards in the original sample. And you usually want to get at least 6,000 And StatKey's struggling to do this because of the large numbers. And I got 6,000, good enough. And then I want to do two-tail. And somewhere in there, they must have said they used a 95% confidence interval. So let's go back and double check that. That would probably be at the end in their methodology page. Here's the methodology page. Here we go. I don't see it. It's going to be here somewhere. Confidence level. There's the response rates. Usually it's here. Control F. Confidence. Occurs a whole lot of times. Confidence, 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 confidence. Usually they put it out in the methodology, but I didn't see it. Huh, okay, I will have to do some more research and figure that out. Maybe it's in the Methods 101 explainer. That's their sampling method though. All right, anyway, it's probably a 95% confidence interval. It's somewhere in some other spot apparently. Anyway, we're just gonna guess that it was. So here I have a 95% confidence interval based on their sample, and mine says that the actual percentage is between 58 and 60%. And when we did our arithmetic, let's see, what did we find? About 58 and 60%. So the simulation matches what they calculated. Again, they probably didn't use the simulation. They probably used a slightly different technique, which is based on a thing called the central limit theorem, which we'll cover in 2 weeks. But it's a whole bunch of theory and formulas, which we're not going to worry about. Okay, so what are the things that we need to be good at here? We need to be good at deciding whether we're doing a confidence interval for a mean or a proportion. Those are the only two things we're looking at. And so that means we're in this section of StatKey for the majority of the problems, and we're either going to select a confidence interval CI for a mean or a confidence interval for a proportion. Once we're in there, if we're not using a data set that they have already, and I think there was a problem where you were going to use either the body temp or the restaurant tips in your homework. So if it's not selecting one of their data sets, then you would go to edit and replace whatever data they have, delete with your data. Double check that these buttons are correct. Do you have a header row or not for the mean? And then if you have a proportion, then I don't think I use any of their data in your homework. I give you data, and that means you have to have the count. That's what I call X. That's the numerator for a proportion, and then the sample size, that's the N. And if you know those two, then you can then run your simulation on that. All right, so we're getting near to the end of the time. There was one homework question, then I just did a couple of problems that were similar. Important things for me are that you can use this tool to find a confidence interval. The other important thing is that you know how to interpret that in plain language to other people. And I gave a few examples back here. These, I have similar examples in the videos about how to do the interpretation. And then the big question from there is, what does it mean to be 95% confident? And that is a little tricky. The book talks about it a little bit, and I'm just going to mention that right now. And that was in the recording on Monday. So what the heck does the confidence level mean? And if you do have a homework question, please put it in the chat or speak up while I write this down. What does a confidence level mean? So a standard confidence level is 95%. And sometimes we choose to be more confident, sometimes we choose to be less confident. And there's a relationship between the confidence level and the size, the width of the interval. More confident, the bigger the margin of error, the less confident, the lower. And that's in one of my recordings from before, and I mentioned that earlier. So what it is it's confidence in the procedure. So if I were to write interpretation of the level, not the interval, just the level, forget about any data, then it would be something like this. Let's see, how to phrase that. 95% of similar samples actually contain the population parameter. And that parameter is either a mean or a proportion for us. There are other things we can measure, but we're not going to get there in this course. Oh, excuse me, I'm going to sneeze. A little pressure point between your lip and your nose that usually stops you from sneezing. All right, got it covered. So it's 95% of similar samples. So like I was doing that simulation, if I have that sample of 44 of you guys and how much TV you watched, if I did 100 samples, each of 44 people, like for the TV time, then what I would expect is 95 of the intervals based on those samples, intervals, actually contain the real mean. 5 of those intervals do not. I have no idea if mine is one of them. So one thing the confidence level is not, it's not the percent that I'm correct. There's not a 95% chance that I have the right interval. I don't know that. It's just, if I did this hundreds and thousands of times, I would expect to find about 95% of the intervals we may contain the mean and 5% don't. And it's kind of like rolling the dice each time. When you roll dice 1,000 times, you're not going to get the same number of 1s, 2s, 3s, 4s, 5s, and 6s, but they'll be kind of sort of the same. We just never know what's going to happen. So this is super important about the confidence level. It is not a percent of success. Not. It is not a probability. Not. Can't emphasize that enough. So that interpretation is just confidence in the procedure. If we do this again and again and again and again and again and again, 95% of the time we'll get lucky and we'll actually catch the real number, but we'll never know what the real number is. Oh, okay, I'm done preaching. Any further questions? All right, feel free to log out if you don't have questions. After this, I'm going to go grade some application 5s, which was the false positive negative rate about breast cancer. And then I'm going to try to get the critical thinking and application posted. And I'll make an announcement about once I have those up, which means you'll get a message that, hey, they're ready with some details. So take care, do good math, and I'll see you in the near future.